Okay, students, so this is on page 110, and we're going to do a scatter plot by hand. Most of the time in the professional world, you would definitely want to use a computer. However, for classroom purposes, we're going to be doing one by hand. We've got a dealership, and they've been using TV ads, and they want to know if the cars they sell is somehow related to the number of ads they run. So in order to see if there's some sort of correlation going on between cars sold and number of ads ran, we're going to make a scatter plot because that is the most basic way to decide whether we should proceed with a regressional analysis or not. So in order to make a scatter plot, you of course want a title, Cars Sold as an Effective TV Ads. We're going to plot the number of cars sold on the y-axis, and we're going to plot the number of ads ran on the x-axis. So get yourself a scale set up. On the y, the largest number is 40, so you need to make sure that your scale encompasses up to 40. And on the x, I believe the largest number is 28, so you need to make sure that your scale can accommodate that. And you want to plot these as ordered pairs, so we're going to go out to 6 on the x-axis because x is 6, and then we're going to go up to 15 on the y-axis. So 6 is right here on my x-axis, and I'm going to go up to 15, which my y-axis I kind of made a mistake on, that's why it looks so messy, but you get the idea. This is an ordered pair, 6, 15. Do you remember that from algebra? We're going to treat each point as an xy coordinate. So 20 on the x and 31 on the y. So we go out to 20 on the x and we go up to 30 on the y and we put a dot. And you can mark the dot what the coordinate is if you like, but we're just trying to get a rough idea, so I'm not going to. 0, 10, 14, 16, 25, 28, so go up to 28 after going over 25 places, 16 and up to 20, and then over 28, I'm on this one right here, 28, 40, so 28 and then all the way up to 40, and 18 and up to 25, and 10, 12, and 8, 15. So that's around in there. So I've got this little kind of dot thing going on. If I try to put my ruler to go through the majority of the dots, because I want to try to see if there's some sort of linear relationship happening, I just kind of draw a rough line like that. And what you can say about the picture is always talk about the slope. The slope is obviously positive, so as the x increases, which is number of ads ran, which is your x variable, so as that increases, what happens to the y variable? The y variable is number of cars sold, which is your y variable. What happens to it? Well, as x increases, y is also increasing. So we say also increases. So that's an interpretation based on the slope of what would be the linear equation. The line of best fit is what it's sometimes called. Another interpretation we can make is we can talk about the correlation. We can say there appears to be. Now this is where it's very subjective. You get to decide whether you want to say strong, weak, moderate, or you can say just some sort. I'm going to go for a Based on my experience, let's go for moderate. Moderate. Talk about what kind of correlation, whether it's positive or negative. It's positive because the slope is positive, so positive correlation between, and then just state your two variables. Number of ads ran and number of cars sold. Okay? More important than just drawing a picture or making a picture is talking about the picture. You must be able to talk about these pictures. I also did this one with a little more spread out scale, so you can kind of get an idea, and my line happened to run through my title on that one, but that was a more spread out scale. FYI. And that's how you do a scatter plot by hand, of course. Again, in the real world, you want to make those with a computer of some sort. But that gives you an idea, and the most important thing, again, is interpretations of these pictures. Talk about your slope, and talk about what appears to be happening with the correlation.